Well, if you watched the last video that I had the link for, this next piece shouldn't surprise you. The way that you get complex numbers or things with imaginary numbers in it is you do synthetic division with the real numbers and the rational roots, that the rational roots theorem we talked about earlier, and then you kind of whittle it down until you get to something you can use the quadratic formula with. And because of the plus or minus in the quadratic formula, if you wind up with one complex root, you should wind up with another complex root. So according to that, if I have this function and I know that 5 plus 2i is one of the zeros, then guess what? Oops. 5 minus 2i should also be one of the zeros. So what we wind up doing is kind of off to the side doing a little bit of work, because I really don't think you want to make a box or do synthetic division with 5 minus 2i or with 5 plus 2i. So what I'm going to do is go through, and if x equals 5 minus 2i, then I'm going to, I don't know why that has a squiggle on it. I'm going to kind of set that equal to 0. If x equals 5 minus 2i, if I have a factor, it was going to be x minus 5 minus 2i equals 0. And if I have a factor of x equals, if I have a 0 of x equals 5 plus 2i, then the factor that that 0 came from should be x minus 5 plus 2i. That's going to need to sit and marinate, and you may need to pause the video here for just a second. All right, since we know those two things are both factors of the polynomial, factors of this polynomial on the left screen here, I'm going to multiply those two things out because I know they should be equal to 0 if these factors came from this polynomial on the left. They should multiply together. So everyone's favorite method for multiplying those together is to use the box. So I can just go through and fill this out. X times x is x squared. Negative 5 times x is negative 5x. This is going to be a plus 2, I don't know what order to put this, 2ix. I know it's not going to matter because they're going to cancel out because they're conjugates. Minus 5x plus 25. And here's where it starts to get interesting. I'm going to have a minus 10i here. And up here, I'm going to have a minus 2ix and a plus 10i. And if you're kind of following along, you can see what's going to happen. And then down here, I'm going to have a minus, whoops, that's wrong, minus 4i squared. So some good stuff's going to happen for us here. We can start combining some like terms. There are no other x squareds, but I can combine these two. I can combine these two, and those are going to zero out. I can combine these two. These are also going to zero out. And then remember that I squared is negative 1. So I'm going to do a little substitution right there. I'm going to put a negative 1 there. And I can combine like terms. So what do I know so far? That if this is a 0, and that means that if that's a 0, then its conjugate will also be a 0. And all of those should divide into our original function. So what do I have? I have, down here in our box, I have x squared I'm going to put them in order. Minus 10x plus, oop, I have to combine this 25 with, that's going to be a 4, positive 4. So it's going to be plus 29. And here's why I did not have you guys zone in on the synthetic division, because that has x squared. We can't use synthetic division on it. And trust me, guys, this is the easy way. So I'm just going to scroll down here. And now that I know that x squared minus 10x plus 29 should divide into that, I should be able to make a box down here that has x squared minus 10x. That should have been a 10x from the previous screen. Sorry. And a plus 29. And all of that stuff should divide into x cubed minus 7x squared minus x plus 87. And I don't think I made my box big enough, but we'll figure it out as we go along. All right, so what goes up here? It's going to be the x cubed. If x cubed is the area of that box, that means if the left side is x squared, the top has to be x. And now I can fill these other in. Minus 10x. Ooh, I hope my mouse work here isn't messing you guys up. And a plus 29x. Hold on. That was supposed to have an x in it. So that should have been x squared, and that's 29x. Got that right. No squared. All right. Now, so that right there wound up going to this term. Well, all of these things here should wind up multiplying, or adding, excuse me, to negative 7x squared. So if that's a 10x squared in this space, I need negative 7x squared. That means this box has to be a 3x squared. And now I can get going again. So, oh, look, maybe I don't need the box. I might get this done earlier than I thought. So if this is x squared, and that's 3x squared, my area has to be 3x squared, so this top's going to have to be a 3, which makes this a minus 30x. And let's see, 29 times 3. Yay, it's 87. It came out exactly right. So just to double check, remember these two are supposed to add to x squared, and that should have came out to be 87. All right, awesome. So what do I know? I know that one of my zeros is 5 plus 2i. I know the other 0 is 5 minus 2i. And my last factor should be x plus 3. In which case, my last 0 should be x equals negative 3. So I don't know if you want me to write the whole deal out, but yeah, I can do a little copy paste and get that down here on the bottom. So your final answer should be 5 plus 2i, 5 minus 2i, and negative 3. So just to quickly summarize, if we know one complex factor, if we know one complex root, we should be able to find the other complex root. They have to be conjugates because of the plus or minus in the quadratic formula. Then, if we know the zeros or the roots, then we should be able to, well, we should be able to find the factors that gave us those zeros, do a little distributing, and distribute our negative, make a big box out of that thing, and it's going to turn out to be some version of a quadratic, which was over here. which now we can divide that into the original and find out, take this quadratic, divide it into the original function, and find out our last root.